Another computer science project, Michelle Guo, advised by Dr. Antoine Girma, identifying security vulnerabilities in public application programming interfaces in Android operating system mobile application development. Michelle, are you ready to queue up your presentation?
Yes, I am ready. I actually did change the title of the research slightly, but it still is related to the topic that you just said. So
Sure.
I'll try to share my screen.
Mm-hmm.
Yep. Okay. Hopefully you can see my screen all right.
Yes, it shows up.
Okay, cool. So hello, everyone. Good afternoon. My name's Michelle Guo. I am a Master of Science, computer science student at UDC. Actually just graduated a few days ago, but I'm excited to share the research that I've been doing this semester along with my advisor who's here, Dr. Antoine Girma. So the topic of my research is identifying shared security vulnerabilities and mitigation strategies at the intersection of APIs, applications, and OSs of mobile devices. So I'll go into what this means for the non-computer science people. So essentially what motivated my research were three questions. The first one was, given the rise of cybersecurity attacks on APIs and mobile devices, what are common vulnerabilities? Now most of us use some kind of mobile device, whether that's Android or iPhone. Especially during the pandemic, we've been downloading many applications, basically becoming reliant on technology. However, we don't always think about the vulnerabilities on our devices or mobile applications or the things that we're using. And that's kind of scary to think about when we just want to use our phones to enhance our daily lives and productivity. So that was a huge motivating factor for my research in figuring out how we can make our daily lives more secure. And the second question, are there differences between the types of mobile OS devices and the security they offer? So differences between iPhone and Android security. The third one is, so basically this research is mostly for what organizations and enterprises can do, whether they're rolling out mobile applications to the public or deploying a mobile application within their organization. What can these organizations do to mitigate these risks when they deploy mobile devices? So my research approach was to identify from three different areas of cybersecurity related to mobile apps, APIs, mobile device OSs, and mobile applications. So these are three very different things. So APIs are basically the interface that allows communication between different applications. So for example, if you have a database and you want to use that same database for a mobile application and also for a web application, you don't need to make a new one. For the mobile app, you would use an API. So many mobile apps use APIs, but I categorize them differently because there are still mobile applications that can be downloaded and used without APIs, although most mobile apps use APIs. And the third category, mobile device OSs. So when I say that, I'm referring to the actual mobile device. So including hardware elements, including like the specific operating system, because Android and iOS are different devices, so they have different requirements. So very briefly, this is an example of how a mobile device can be exploited. So from the very top, you can have a legitimate mobile application sending out an intent broadcast message to different users. And sometimes that data can be intercepted by a malicious mobile app. And that information, if it lands in the hands of an attacker, that could be bad because that could be your confidential, sensitive information. It could give them permissions to access certain things in the application they wouldn't otherwise be able to. through information
And was this just
leakages
sort of a friendly
and
conversation,
such.
cooperative conversation? Any threats made to him that he had to talk
So very briefly, to process how mobile attacks data and vulnerability data, how these can be used. So when these actually are identified, many companies will use some kind of machine learning to classify these different vulnerabilities and attacks so that organizations will know which ones to target. However, there isn't too much research on the intersection of APIs, applications, and OSs. So that's another motivating factor for my research is what are the similarities and are the strategies we can use to combat all of those things. So very briefly, some API security vulnerabilities include broken object level authorization, broken user authentication. Authorization and authentication are two different things. Authorization are basically the permissions that you're given to access certain things. Authentication, you can think about multi-factor authentication if you're trying to log in somewhere and you get an email or a text message that verifies that you are the person trying to log in, not somebody else. And excessive data exposure, lack of resources and rate limiting, broken function level authorization, mass assignment, security misconfiguration, code injection, improper assets management, and insufficient logging and monitoring. So these all have different exploitability levels, prevalence, detectability, and impact. They vary, but what we need to know basically is even if the impact is moderate, it can still have very severe consequences. Any kind of vulnerability can have severe consequences. So very briefly, mobile app security vulnerabilities. So some of these overlap with APIs, but there are some differences. So first is insecure data storage. Second is insufficient transport layer protection. Third is insufficient authorization and authentication. Fourth is cryptography and improper certificate validation. Fifth is brute force and user enumeration. Sixth is improper session handling. Seventh is information leakages from application cache. 8 is weak server-side controls, and 9 is lack of binary protection. So that's for mobile apps. And next, we'll go over mobile OS operating system device vulnerabilities. So big ones are 1, denial of service, 2, bypass vulnerabilities, 3, execute code, 4, memory corruption, 5, overflow, 6, gain information, and 7, gain privileges. And very quickly, the differences between Android and iOS is that Android OS primarily has an open source system. So this means that you can see code from applications, download it from the Play Store. It's accessible code to the public, which has its pros and cons because for one, this allows for more research in the Android security field, but it could have a con in that people are seeing the code, so they can figure out how to exploit even more vulnerabilities. iOS is different in that it's more of a closed system. There are a lot less user permissions that you're granted on your phone compared to compared to Android, where you can grant user permissions to, for example, access your device's power, memory, other things that affect the overall systems, whereas iOS, that's less prevalent. And it's for iOS, when you try to upload applications to the Play Store, it's a more rigorous process. It takes a longer time to upload your application to the public. Android, it's a lot less rigorous. It's also faster, so they do have a lot more applications there. However, that also requires more discretion on knowing which kinds of applications to download.
You're at 9 minutes, okay?
Oh, thank you. So very briefly, we talked about vulnerabilities. So now we'll go over types of attacks that people can use to exploit these vulnerabilities. Those are two different things, vulnerabilities and attacks. So one is untrusted APKs, basically using packages from untrusted developers that could contain malicious code, even if the developer has good intentions. 2, SMS messaging, smishing is one of those things. 3, email phishing, annoying emails that you might get saying your friend is stuck in Europe, they need money, send it over. It's not really your friend, it's really an attacker. 4th, spying. 5th, cloak and dagger. 6th, smudge attack. 7, DDoS, and 8, man-in-the-middle attack. So basically from the research, the 3 main categories that were similar between all were 1, escalation of privilege. So this has to do with authorization. 2nd, information exposure. And 3, authentication bypass. So essentially authorization, authentication, and data handling and leakage were the main categories in common between all of these. So some of the vulnerabilities we already talked about. In the interest of time, I'll just skip to mitigation strategies. So a lot of the mitigation strategies between APIs and mobile apps are very similar, but there are some differences in that mobile applications, they're dealing with these APKs, APIs, they need more research in comparison to mobile applications because many people just see it as an interface. A lot of security is out there for mobile apps, but not so much APIs, which is an important point. And mobile device OSs, enterprises have the least control over that. It's more up to the manufacturers. However, there are still things we can do, such as using multi-factor authentication, limiting control and access to avoid DDoS attacks, and regularly inspecting traffic. So for future works, it would be interesting to see how this plays with 5G mobile networks as it continues to roll out to people, and analyzing security hardware components. So some mobile app manufacturers are doing this, for example, separating your sensitive data from the actual operations of the phone into 2 separate chips. So those are potential avenues for more research. So in conclusion, by addressing these overlapping vulnerabilities, enterprises and organizations will have better mobile security in regards to access control, authentication tokens, and denial of service across analysis of APIs, mobile apps, and mobile OSs. Thank you very much, and happy to answer any questions and seeing everybody else's presentations.
Thank you very much, Michelle. Are there any questions? We have probably time for one question. Any? Okay, then thank you very much again. Our next talk will be by Davies Aklamadi, also advised by Dr. Anthony Girma, Integrated Security Analysis of Autonomous Vehicle Systems. Davies, are you ready to go?
I'm ready. Let me just share my screen real quick.